Broadcasting live. It's America's longest running talk show on computers. It's Computer America, bringing you the biggest names in technology with guest interviews, new products, and your emails. Listen live at computeramerica.com on any device around the world. Email the show at live@computeramerica.com or find us on social media. Be sure to check out our website for contests, giveaways, show notes, live video stream, podcasts, and more. You're listening to Computer America.
Hello and welcome everyone into the Computer America Show. We are the nation's longest running, nationally syndicated radio talk show on computers and technology. And everyone, welcome into the Computer America Show. I hope that you are doing well and you are ready for today's program because we have an amazing show lined up for you that Ralph has lovingly put together, hand-stitched these show notes, and you should definitely come check them out at computeramerica.com, where we have 4 different stories, all of them amazing. Actually, more than 4 stories, but we will get to that later. But you can find them in the show notes at computeramerica.com, as well as anything and everything that we do here for the show you can find in one place. So go ahead, check that out. Everyone, I hope that you've had a fantastic week and you are ready to head into a Friday with something a little bit more fun. And don't get me wrong, this week has not been all bad news. There's been some craziness going on, but I did want to give a special shout out to what I assume is the James Webb, which, if anyone wants to correct me, go for it. But finding the best evidence yet that supports life on another planet. Stuff like that. There are amazing stories that tend to trickle through, the information sphere out there. And, well, there's that amazing story, but also Ralph has found 4 stories that you probably haven't heard of, or you might not have heard of, and you're going to want to check those out. So we'll go ahead and get to that one last time. Computer America, if you want to know anything that we're doing, there you go. Now, our science and tech trends correspondent, Ralph Bond, has been with us for a long time, and we do a number of stories that are good, important, research, but also, hey, some of these are, things that you can actually interact with. You can see they will affect your everyday life. So let's go ahead and bring Ralph on and just have fun on this Friday. So Ralph, welcome back onto Computer America. How you been?
Okay, well, it's great to be back. And folks, if you're first-time listeners or viewers, if you're lucky enough to see the YouTube video, which I highly recommend, welcome. What Ben and I do each Friday is highlight 4 recent articles that show us key trends and developments in a host of things, including artificial intelligence, robotics, medical technology, sustainable energy technology, transportation advances, agricultural technology, space research, physics. I could go on. It's everything. You name it. But most important of all, we're going to give you an oasis of positive news. God knows we need that. Thanks to the world of science and technology.
Absolutely. So, and before we even jump into all the stories, I just wanted because I know that you're big into space as well, and we do a lot of space here on the show, and seeing the fruits of other people's hard work and intelligence and time, and I just get to go, wow, that's cool. What do you think about the most compelling evidence for life on another planet? I mean, that's pretty cool.
I can't wait for the day, and maybe I'll live to see it. I hope I do. When they conclusively confirm the existence of life outside of the planet Earth, because that will take us down a notch of arrogance real fast. I think it'd be just great, even if it's just little tiny cellular stuff. Anything.
Yeah, just little phytoplankton, and yes. the best implication I've heard from that is if we can conclusively prove that there are at least like phytoplankton on another planet, that at least means that, hey, of the 0.00001% of the universe that we have kind of checked out and we found other life, what does that mean for the other vastness of the universe? It means it's not so lonely out there. So
exactly. And to your point, they constantly keep finding additional evidence potentially of life having existed on Mars. Mm-hmm. So that's another thing that's kind of in parallel with all of this, and they just keep going on and on. And one of the moons, what is it, Titan, or one of them they think could Europa, possibly have life? One of the moons of one of the great planets could possibly support life as well. So I think we will find it eventually. and hopefully I'll get to see that day.
I'm sure you will, because I'm sure we can't be too far. So
Yeah.
either way, geeking out about space stuff, always fun. But we have other stories to geek out about.
Yeah.
We have bendable batteries. We have light-based computers, something that we've touched on here and there. We have amazing medical breakthroughs. But Ralph, let's start with story number one, and this one's a little bit different because it's piggybacking, no pun intended, on robotic dogs that we've seen before. But this time, Ralph, they want you on them. So story number one.
Yes. Yeah, this is really fun. It comes from Robotics and Automation News. The headline here is Kawasaki, that's a brand name I think many people know, unveils hydrogen-powered robotic horse. No, they call it a horse, that you can ride. And I think the horse thing is because you can ride it like a horse, but it looks more, to your point, like a robotic dog, like a great big one. And folks, come out to computeramerica.com, get the show notes, or if you're lucky enough to be watching this on the video, you're going to see the images that'll show you what this prototype thing looks like. It's very freaky, very cool looking thing. But here, let's get into the story. Kawasaki Heavy Industries has unveiled Corleo, Corleo, a hydrogen-powered, four-legged robotic vehicle designed for riders. And they did this at the Osaka Kansai Expo 2025, which was opened on April 13, so very recent. This innovative concept integrates artificial intelligence and clean energy technologies to navigate diverse terrains. That's the goal. And Ben is showing you the animation that they have provided to give this concept some life. Now, a reality check. This is a big reality check. Currently, it's a concept prototype, and it's there for display purposes only at this stage. And any videos like the one that Ben is showing you, they're animations. And Kawasaki envisions bringing this to market. Well, you're going to have to wait a while. It won't be until 2050. So this is very futuristic concept sort of stuff. And in a way, I kind of scratch my head and think, if you're talking 25 years out, why did you do this? I think it was, and I don't mean to demean this news in any way, shape, or form, kind of a publicity stunt, but still fun and interesting to see where thinking is going with regard to robotics of this type.
Yeah, and for even what we do, even when research papers and stuff like that, kind of happens, even early research is usually 10, 15 years out. To be 25 years out, I mean, and let's just face it, I think we're all bombarded with so much AI generated video and pictures and so on and so forth nowadays that I'm not saying this is a bad use of AI by any means. They clearly have a concept model. They clearly want to move in this direction. But I think making presentations like these, Ralph, they're still kind of new and exciting. And I'm sure some animation has been touched up in the studio. But making stuff like this is going to be all the easier. Kind of say, here's what we want. Here's what we have. This is where we envision it going. And then they put out a video like this. Very cool, but also, you're getting to the, this stage much earlier than you would in the past. But it's still a very cool idea.
Yeah, it is. And this is a good example, Ben, especially this is good for new listeners, new viewers. We look at things often that are early research trends, things that don't happen or aren't going to be available next week at your local store, but things that are forecasts of where we're going in the future. So this is a really good example of that, and probably the longest telescope range, 25 years, that we've ever done. But with that said, let's go on here. Corleo's four independent robotic legs enable balance and stable movement across various surfaces. Each leg operates separately, allowing the robot to traverse rough and uneven terrain with ease. And it's equipped with a 150 cubic centimeters hydrogen engine. Corleo generates electricity to power its limbs. This clean energy approach positions, the robot as an environmentally friendly off-road mobility platform. And Corleo features a streamlined body composed of metal and carbon materials. Its front end includes a head-like shield complete with built-in lights for visibility in various lighting conditions. And instead of a traditional steering controls, Corleo responds to the rider's body movements. Shifting the center of gravity prompts the robot to adjust its steps accordingly. Pretty sophisticated stuff.
Yeah, and this is all stuff that, while again, the timeline is very kind of out there. This is all stuff that we've already seen from some of the robotics dogs from like Boston Dynamics is the most famous one. But it's all possible. It's just putting it into a different packaging, increasing the scale and the payload, and actually putting, I guess, a human on it. And that part is a little daunting.
Yeah, and the last little nugget on this is it has a heads-up display and providing real-time information on the vehicle's hydrogen levels, navigation, and movement stability, including weight distribution. So a concept, boy, I tell you, 25 years out, but a concept that's pretty fun and pretty interesting. And I think, Ben, maybe more important, this might inspire other manufacturers, other producers of robotics to look at this and say, maybe we can do something sooner than 25 years out.
Yeah, honestly, thanks to a hurricane in the mountains a couple of months ago, I've become pretty familiar with ATVs. It's a fun little vehicle, but it really kind of highlighted me the limitations of something like that in just kind of navigating around, Ralph. It's it's not the worst thing in the world, but also it tears up the ground. It's really ATVs are very loud and smelly, and they just rip up the earth. Something like this, and obviously they were putting the video in like mountain streams and idyllic, almost Nordic looking places. But like it would be much more environmentally friendly, and this would get a lot more places than 4 giant wheels could get you. So it's think of it like the next version of an ATV. It's just a little dog-like, and you might have to give it a name and give it flea and tick medication every once in a while. It's cool. It's really cool.
Fun concept.
So there you go. Story number 1. And ladies and gentlemen, if you didn't get to check out the video, it's only like a 1-minute video. Definitely go check that out. So story number 1. Story number 2, let's go ahead and jump on over to computers. And this is something that, we've talked about here and there, and you've added some notes that really highlight to people, kind of why this is such an important breakthrough, which we'll get to in the article. But light-based computers, right now, not exactly light-based, we're electron-based. Instead, these are photon-based, like you're going to say. So let's go ahead and talk about, potentially light-based computers coming to market.
Yeah, exactly. And this story comes from New Scientist. And the headline here is light-based computers are getting close to a commercial launch. So friends, this is an example, a classic example of a trend story. As Ben was alluding, light-based computing is not mainstream right now, but again, this article talks about another incremental step forward. And so we're going to do a little bit of refresh and review. This article is a good example of the growing interest in photonic computing, and it emphasizes the potential for photonic computing to revolutionize data centers and computational tasks. So this is very much aimed at an audience that's interested in data centers, these gigantic buildings. And Lord, we have a bunch of them near where I live in the town of Hillsboro, Oregon, outside of Portland. They're building data centers around our beautiful farmland faster than you can think. But this is where this is aimed at. And reminder, as Ben mentioned, photonic computing represents a key breakthrough. Computers using light to process data are nearing commercial application, the article talks about. And these devices are faster and more energy efficient compared to traditional electronic computers. And there are so many advantages to photonic computing. And again, this is a little refresh to set the stage here. Photons move faster than electrons, speeding up calculations and reducing delays between computational steps. You can see why they're so interested in this. And by the way, a little side note on my own here, the combination of quantum computing and photonic computing, wow, you can see the potential here.
Yeah.
And the photonic chips use less energy since photons move without resistance and generate less heat, minimizing cooling requirements. Cooling requirements, you ought to see the cooling towers and all the stuff on these buildings around where I live at these data centers are massive. That's why data center people are paying attention to these kinds of stories. Now, finally, here's the news. There's an outfit called Light Intelligence. It's kind of the combination of the word light and intelligence. Light Intelligence, a company specializing in photonic computing, has developed a photonic Arithmetic Computing Engine. They call PACE, PACE. Of course, it has to be an acronym. Everything has to be an acronym, right? And this combines photonic and microelectronic chips, a hybrid, to run practical problems such as the icing problems, which are relevant for logistics and other industries. And Ben, I said, what the heck is an icing problem? ISING. I hope I'm saying it right. Mm-hmm. And I've got a side note in the show notes. We're not going to go through all the details. What I do is I inject tutorials into the show notes when I don't know what the heck they're talking about. And believe me, I didn't know what an icing problem is. But very briefly, icing problems are mathematical challenges based on the icing model, which is a concept in statistical mechanics. And if you want to geek out and learn more, come to the show notes. But here's the key takeaway. This announcement is relative to progress toward commercialization of photonic computing. Lightelligence's photonic chips, now here's the key, Ben, they can be manufactured in the same factories that produce silicon chips, facilitating adoption. So that's what this company has done. We're talking about a hybrid of traditional and photonic computing aimed at data centers. But the key is these devices they've come up with, these photonic chips in specific, can be produced in existing silicon chip factories. So that's why this is an important leg or move forward toward commercialization. Pretty cool.
Yeah, no, very cool. And by the way, to kind of hammer the cooling needs, and you're mentioning the water towers. I just want to Google real quick just how much water is used. For one example that they pulled up, they said that a cloud service provider and one of their data center facilities can use up to 550,000 gallons of water per day. A mid-size one could use about 300,000 gallons per day, which is enough for about 100,000 homes. So, and then you have Google, which uses about 4.3 billion gallons of water globally, and I believe that's per year. So 4.3 per year billion gallons of water. So you could, so cooling is such a huge concern, and to be able to mitigate that, and I'm sure there's lots of redundancies. You mentioned the speed, a lot of upsides to this, and of course, easy manufacturing, not the least of all. So very cool technology.
Yeah, very cool. And again, photonic computing represents less energy required as well. So not only lower heat, but less energy. So both of those things are extremely attractive.
Perfect. Yep. So that's story number 2. And story number 3, we're going to go ahead and get down to those bendable batteries, because for anyone out there who's kind of run over their phone, or they have dropped something and the battery just kind of, breaks, or, the casing to it kind of goes away and it starts to smoke and it's kind of reactive with oxygen. It's a very bad time for batteries right now. They're rigid, they're hard. It's not good to puncture them, break them, shatter them. Well, story number 3 might be an answer to maybe not your phone, but to getting batteries in more places, and you don't have those same limitations. So story number 3.
Yes, so this is a good one. SciTechDaily is the source for this one. The headline is "The Shape-Shifting Battery That Powers the Future of Wearable Tech." Wow. And actually, this news comes from a university in Sweden. We're going to get into that right now. This article highlights a groundbreaking battery developed by researchers at, I hope I'm saying this right, Linköping? I'm not sure.
Looks right.
Linko with an umlaut over the O, Ping University in Sweden. So this is a really interesting development. And here are the main points about it. It represents a revolutionary design. The battery is a flexible, stretchable, and shape-shifting power source that departs from traditional rigid batteries. Its electrodes are converted the electrodes are converted from a solid to a liquid state, described as having the texture of toothpaste, which allows it to be molded into virtually any shape, including using 3D printing techniques. There's a lot of what? Mm-hmm. And it uses sustainable materials. It's not only flexible and malleable and all this good stuff, uses sustainable materials. This innovative battery harnesses sustainable components such as lignin, that's lignin, a byproduct of paper manufacturing, and conductive plastics. This not only minimizes the environmental impact, but also circumvents the reliance on scarce or hazardous metals often used in conventional batteries. Wow. In the show notes, I have a side note about what is lignin. You can check that out if you want. Going on here, it says it offers great performance and durability. Despite its malleable nature, the battery is engineered to maintain stable performance even when stretched to double its original length. Wow, Ben.
for everyone who can see the video portion, you can see the picture there. Think almost like a Tide Pod. It kind of has like a clear swirl to it, and that swirl, I guess they kind of chose to really highlight just how precise they can kind of get the fluid in there, and it can take any kind of shape, including a weird, freaky, spiral pattern, which is not something that's obviously what's going to make it into the end product, but it shows just like the extent to which they can really customize this, which is, a lot.
Well, yeah, and Ben, this picture you're showing is also helpful because it shows two people. There's four hands here, each one at each corner, pulling and stretching on this guy. But the point it makes also is we're not talking about gigantic, large batteries at this stage. Their prototype is very small, maybe about, what do you think, like an inch and a half or something in diameter, if I had to guess. So that's another point. And here we go. It goes on to say it has demonstrated longevity through hundreds of recharge cycles without compromising its output, making it highly suitable for dynamic applications. Now, possible future applications for this new malleable battery with the advent of wearable technology, and boy, Ben, we've covered that a lot in the last several years. So with the advent of wearable technology and the anticipated surge in connected devices, this battery could play a pivotal role in powering a wide range of future innovations. And to wrap it up, it says potential uses include wearable health monitors, soft robotics, electronic textiles, we've talked about that a lot in the past, and even implantable medical devices, all of which are applications where flexibility and conformability are essential. So very cool technology coming out of Sweden. Let's see where this goes.
Yeah, no, and you can imagine, putting it into, let's say, a pair of like smart pants that are going to be health trackers or training assistants, being able to put that battery pack, let's say, along the entire leg, and it doesn't reduce your range of motion, would be, a lot more battery than just having it somewhere, that could even hinder performance. So yeah, a lot of different applications. Love it, and the picture really shows just how much you can mess with this thing, which is a lot. So very cool. Story number 3. Story number 4. Last story of the day, and Ralph, I think we're going to talk about. This is ethical, I believe. I'm sure there are ethicists out there that could probably make an argument better than I ever could that this is not ethical. But you know what? If this thing's only existence is to feel pain, then hey, who am I to judge? But this could have huge implications for not just rat lives, but for all people's lives. And this is really an amazing breakthrough. So story number 4.
Yeah, you make a good point. I actually hadn't really thought about this as being something that it contributes to using this technology instead of animals, whether they're mice or rats or primates. They're still doing tests on primates. There's a huge, giant controversy going on right now here in Oregon with OHSU, which has a primate lab, and they've been doing tests on them, and there's a lot of controversy about disbanding that because of the impact on these little animals. But with that said, this story comes from ZME Science. The headline is Scientists just built a mini human nervous system that can process pain in a dish in a world first. Wow. A lot of things going on here. I think in the end of the day, net positive.
Yes.
So neuroscientists at Stanford University have grown a tiny 2-centimeter long They call it sausage.
I love
made of
that.
Yeah, that's funny. And if you see the picture, it's a rather misshapen sausage. But anyway, so the Stanford University, they've grown a tiny 2 centimeter long sausage made of human cells that may hold answers to one of medicine's most persistent mysteries, that being how pain moves through the body and how to stop it. Now, this is amazing. Get this. 4 million cells were coaxed into becoming tiny brain-like structures called organoids. And Ben, you and I have been talking about organoids. If you want to talk about a trend in medical science and research, organoids. Then, like parts of a machine, those organoids were linked together to recreate the neural highway that lets us feel the world. From a pinprick to a warm breeze, every sensation you perceive begins its journey along this ascending sensory pathway. And for the first time, here's the big deal, scientists have recreated the entire human nervous system's pain circuit in the lab, from the skin's nerve endings to the somatosensory cortex of the brain. And in the show notes, I have a little insert here on what the somatosensory cortex of the brain is all about. If you want to dive into that, you can.
Yeah, and by the way, I completely retract my earlier statement because I've now realized that feeling pain is very different than having consciousness and feeling pain. So, no, this is an all-around good thing. So.
Yeah, it's tracking if you wanted to think of it like a circuit or a motherboard, it's tracking how that pain information goes through the system without having an entity experience or feel pain. So it's
which
like
is great.
Watching a flow of traffic, if you want to call it that.
Yeah.
So going on to the article here, it says this achievement offers an unprecedented way to study not only pain, but also touch and movement at the cellular, and they call it circuit level, opening a door to potential new therapies for sensory disorders. Wow. And to wrap things up here, here's a quote from one of the lead authors of the research paper. Quote, "We can now model this pathway non-invasively. The lab-built circuits or tissue don't feel any pain." To your point, Ben, they transmit nervous signals that need to be further processed by other centers in our brains for us to experience the unpleasant, aversive feeling of pain. So it's studying pain mechanics, learning how maybe we can mitigate or block pain mechanics without an entity or creature experiencing that pain, all done with lab-grown organoids.
Yeah.
Wow, I love it.
Yeah, and that is a trend that we love to see is, just the more that we can put into petri dishes and the more complex the organoids that we can get, the less we need to rely on different kinds of testing on different animals. And we can just, do it much faster, much better.
Yeah.
And hey, maybe even virtually. That's also a trend that we've been watching.
Yes.
Right. And before we get to the honorable mentions, I'm totally curious about this. And Ralph, I don't know if you've heard, and it's made headlines for every once in a while about people who don't feel pain, people who and it's really important in like kids because, they'll touch like a hot stove and they won't know that they've been burned, stuff like that. I'm wondering if like that could help that kind of research where, it's obviously they don't feel pain and something in the pathway is messed up. Maybe something like this could help research in that field as well to make people feel pain because, that could be good. So,
yeah, that's interesting. That hadn't thought about that, and that's fortunately a rare condition.
Yes, very, very rare, very, very rare. But hey, this is super cool, and good luck to the sausage. I hope it feels all the pain that it possibly can. Okay, so that's our 4 stories. We're going to move on to our honorable mentions because if you've been following along, because by the time that you hear this, you'll be able to find the show notes up on the site. At the end, we try to keep the show more condensed for easier listening, and we've been doing a really good job of that lately. Well, I don't want to leave you all feeling that we chose 4 because everything else is bad news. Nothing else is good news. And Ralph can only scrounge up 4 different stories. No, we have a lot of amazing stories that you can find on our site over at computeramerica.com. And these honorable mentions are ones that we probably would have done in the past. It's just we don't have time for it today. So go to the site, check out the links, read the highlights that Ralph puts in the show notes himself. And yeah, you can find out more information, and we will at least leave you with the headlines before we go. So Ralph, let's go ahead and do that at least.
Yeah, so we've got 4 honorable mentions. This first one comes from The Times of Innovations, kind of a fun title for this outlet. And it's scientists in China have turned moss into oil-sucking sponge with 90% reusability to fight deadly oil spills. Wow, that's kind of interesting. And it's reusable with 90% reusability. Wow.
That's amazing.
Yeah, that's quite a good story. And check it out, folks. Come out to the show notes. Next one comes from IFL Science. Headline: Scientists find one life form that could survive extreme extraterrestrial environments. And you'll find out it's good old lichen. How about that? That's a good one. Check that out. That's a fun story. And the next one is, in a first, breakthrough 3D holograms can be touched, grabbed, and poked. And if you're thinking Star Wars, so am I. Wow, this comes from livescience.com. Very interesting. The videos, the images are really, really interesting on this. It's a big breakthrough. We'll see where we go with that one. Mm-hmm. And the last one is more of a kind of survey or research paper information. This comes from the Renewable Energy Institute. And the headline is Clean Energy Surges to power 40% of global electricity in 2024. So it's a paper that's just come out recently saying, hey, last year across the world, 40% of our electricity was created with clean energy, wind power, hydropower, all the combination thereof. I think that's a very encouraging trend.
No, you'll love to see it. And as, regardless of what the headlines say, Ralph, eventually it's only going to make sense to harness all that free sunshine and wind and so on and so forth. It's just going to be the economical choice. And at that point, we will see a real innovative shift in, energy. And looks like that shift is already happening and is accelerating. So, it's great. Ladies and gentlemen, the music means that we are heading out of here. Again, if you want to find out anything that Ralph has put together or anything that we do here for the show, computeramerica.com, you can find it right there. And everything you need to know. So until next week, do something fun. Have a great weekend. We will catch you here next time. Thank you for tuning into Computer America. And everyone, we'll see you next week. Have a good one. Bye-bye.